So this is limits by rationalizing. We're going to continue with the examples from the previous video. Now here we have example 2, and we have the limit as x approaches negative infinity, and the function we're dealing with is the square root of x squared plus 2x plus x. Now the first step towards rationalizing is to get rid of the surd. And since the surd is now in the numerator, remember there is a denominator of 1, but we just don't see it. So we are trying to get rid of the surd in the numerator. And after we rationalize, the surd will appear in the opposite part of the fraction. So from being in the numerator, the surd will appear in the denominator. Now in the previous video, we looked at how to do this. So applying that rule, we are going to multiply this function by the square root of x squared plus 2x minus x. Remember, the sign in between the two terms changes, and that is going to be over itself. Now we are going to multiply. So it's as if we are multiplying two fractions here. So multiplying the numerators together, we're going to have this square root times itself. So the square roots are going to cancel, and we're going to be left with x squared plus 2x. So we're left with what was underneath the square root. Now, to save us a bit of time, I showed you in the previous video that when you multiply the surd by negative x, and then you're going to multiply this positive x by the surd, they are going to be like terms of the opposite sign. So they're going to cancel out with each other. So I'm going to skip that step. We're now going to multiply positive x with negative x. That is going to be negative x squared. And in our denominator, we've got the square root of x squared plus 2x minus x. So this is what I was talking about, where I said that when you rationalize, please remember that wherever the surd appeared in your fraction, after you rationalize, it will appear in the opposite part of the fraction. So notice here, it was in the numerator of our fraction. After we rationalize, the surd is now in the denominator of our fraction. Okay, if we look at what we have left, looking at our numerator, we notice that we've got x squared minus x squared. They can cancel out with each other. So in our numerator, we are just left with 2x. Now, the next step, and this comes from limits at infinity, since we are dealing with x approaching negative infinity, so we are going to follow through with steps from that section. If you are unfamiliar with limits at infinity, I have posted videos on it, so you can watch those videos to review the steps. Now, what we're going to do underneath the square root is we are going to pull out x squared as a common factor. In the first term, we are left with 1. In the second term, we're going to be left with 2 over x. Now, x squared times 2 over x is going to give us 2x, so that does work out. And next to that, we have minus x. Our next step is to allow that square root to cancel out the square from x squared. So in doing so, we are going to end up with x. So the square root and the square cancel out. However, we are going to have the absolute value of x. And now what's left underneath the square root is that bracket, 1 plus 2 over x. Next to that, we have minus x. Now, just to refresh your mind, we choose the absolute value because x could either be a positive or a negative. However, when we decide what x is going to be, we look at the values that x is approaching. Our limit indicates that x is approaching negative infinity. So let's just make a note of this on the side. For this particular question, the absolute value of x is going to equal to negative x. And the reason why it equals to negative x is since our x values are less than 0. Notice that x is approaching negative infinity. So in the denominator where we have the absolute value, we are going to replace that with negative x. Everything else will stay the same at the moment. Now our next step is to factorize. If you look at the denominator, you notice that you have two terms that have negative x in common with each other. So we can pull out that negative x as a common factor. So numerator remains as 2x. In the denominator, let's factor out that negative x. In the first term, we are just left with the square root. And in the second term, we are going to be left with positive 1. Now that we've factorized, we notice that x from the numerator and x from the denominator cancel out with each other. Since we've cancelled out x, we can now make use of the limit. So in our numerator, we are just left with 2. In the denominator, we have negative into. Underneath that square root, we've got 1 plus. Now remember from limits at infinity, a constant over infinity is going to be 0. So we have the square root of 1 plus 0 and then plus 1. Simplifying here, in our numerator we have 2. In the denominator, we've got the square root of 1, which is 1. 1 plus 1 is 2. And there was that negative in front. So we end up with negative 2 in the denominator. And 2 divided by negative 2 is negative 1. So that is our final answer. Let's look at one more example. Okay, let's just clear up a bit of space. Now this is going to be example 3. For example 3, we have the limit as x approaches positive infinity. And our function is now 1 over. In our denominator, we've got the square root of x squared plus 5x. And next to that, we've got plus x. So our first step is going to be for us to rationalize. Now, just bear in mind that since the surd appears in the denominator, when we rationalize, or after we rationalize, the surd will now appear in the numerator. So we're going to have the square root of x squared plus 5x minus x all over the square root of x squared plus 5x minus x. Okay, so remember, to rationalize, you multiply. Now, to simplify, we're going to multiply the numerators together and then multiply the denominators together. In the numerator, we're going to have x squared plus 5x minus x. And in the denominator, when the surd multiplies with itself, when the square root multiplies with itself, it cancels out. So we're going to be left with what was underneath the square root, that is x squared plus 5x. Remember, we don't need to show this, but just bear in mind, when the square root multiplies with negative x, we have negative x of the square root. When we're going to multiply positive x with the square root, we have positive x of the square root. Those two are like terms, they will cancel out, so we're not going to show it. Then we have plus x times negative x, which is going to give us negative x squared. Now, in our denominator, we can actually simplify. We notice that we have x squared minus x squared that are like terms, so they can cancel out with each other. Now, our next step after rationalizing is to simplify underneath this third. So we are going to pull out x squared as a common factor. In our first term, we're left with 1. In our second term, we are left with 5 over x. And next to that third, we have negative x. In our denominator, we are just left with 5x. Now, the whole aim of you pulling out x squared is so that the square root and the square can cancel out. So once that happens, we have x, and underneath the square root, we have 1 plus 5 over x. Next to that, we have minus x all over 5x. Now, the next step is for us to factorize. So in our numerator, we notice that both terms contain x. Let's pull out x as a common factor. In the first term, we are left with the square root. In the second term, we are left with negative 1. And that is all over 5x. So our aim, once we factorize, is so that the x can cancel out. Also, let's just mention, why did we leave this x as a positive x? The reason why we did that is because x is approaching a positive infinity. So we are dealing with positive x values. Notice in the previous example, once we factored out, we replaced x with negative x. That is because x was approaching negative infinity. Okay, so as we go along, because we are understanding the steps a little better, so it's not necessary to show every single step. Okay, so here we just replaced x with a positive x. Okay, so the absolute value, which it actually supposed to be here, let's just correct this, absolute value of x was replaced with positive x. Okay, so let's continue. Now, the x that we factored out is going to cancel out with the x from the denominator. Now that we've simplified, we can now make use of the limit. So we have the limit as x approaches, or rather, we are making use of the limit, so we don't need to write it. It's going to be the square root of 1 plus, substituting infinity into 5 over x. 5 over infinity is going to be 0, minus 1. Simplifying this, underneath our square root, we are left with 1. Okay, and let's not forget the 5 from the denominator. Underneath the square root, we are left with 1. So we have 1. Square root of 1 is 1. 1 minus 1 is 0. Now, just to show you what we have here, we've got 0 over 5. And 0 divided by anything is 0. So our final answer for this question is going to be 0.